Hello and welcome to this webinar in the Prague Inspire Hackathon series. Today we have a very interesting program, of course. We are talking about artificial intelligence, how that is being used on territorial planning, and we will also see how we can compose environmental atlases using social media and old-fashioned mapping techniques. So my name is Bente Liljaby. I'm going to be your host today. And before we start on the program, we will give people a little bit of time to get on to our webinar. So the tradition is then to give weather reports. So we will start with the weather report from the Czech Republic. Karol, how is the weather like in Prague? I assume you are in Prague.
In Prague, now again it's returning winter. We have around 0 and there is sunshine, so weather is good. It is expected that today will be something like -10 or tonight, so the winter is coming.
Oh, really good old-fashioned winter. And
yeah.
Yes, and Ivo, how is the weather and where are you?
I'm in Lisbon and the weather is just like always. It's always sunny. Sunny Lisbon.
Sunny Lisbon, sunny Portugal, huh? Yes. Well, I'm talking to you from Norway, and in Norway we have beautiful winter weather today with sunshine and around 10 minus. So it's well, yeah, it's still good skiing weather. So with that, I will also make you aware of the possibility to ask questions to the speakers. So you will see that there's a chat box where you can ask questions. And we would love for you to tell us, as a start, to tell us where you come from and what's the weather like. To join this weather report tradition we have here. Now, while you are listening to the speakers, you can write questions in the chat box, and we really encourage you to do that. We want to hear what you are concerned with, and we will try to help and answer the questions the best we can. We will have questions after each of the presentations and also a Q&A at the end of the webinar, so you know that. And with that, I think we can start and learn about artificial intelligence. Ivo, the floor is yours. Well, sorry. First, you have to introduce yourself so people know who you are. I almost forgot. Well, Ivo, who are you? What do you work with?
Okay, so my name is Ivo Fernandes. I work at Demos Engenharia. I started working at Demos in October last year, so I'm a very new guy here. I graduated from the Faculty of Engineering of University of Porto. I have a master's degree on informatics and computing. I've always been interested in artificial intelligence, and I did my master thesis on deep learning applied to named entity recognition. So trying to get computers to understand humans, it's not an easy task. And yeah, I joined Demos after that, and I'm working on machine learning and data science.
Ah, super exciting. It's really the future technology we are talking about here. And then Karol, you also have to introduce yourself.
Hi, my name is Karol Harvat. I am, could be not on the big on end of my career. Yes, I am already in the age of senior, and I studied many years ago on computer science, but it was in prehistory. Yes, it's very different technology. Then now I am working a lot now about us could be project manager or technical manager, and I am managing some research projects. And the main topic is geospatial data visualization with on environment or agriculture.
Excellent. We say that the Inspire Hackathons is for experts of all ages. So we all belong in this group. So I told you my name. My name is Bente Liljaby. I'm here representing both Plan for All, who is the initiator of the Inspire Hackathons, and I'm also representing a Horizon 2020 project called NextGeos, which is building the next generation European data hub and platform. So, but now, Ivo, we look to the future and artificial intelligence. You can go ahead and start your presentation.
Okay.
And we will mute ourselves and disappear, and don't fear, we will come back again.
Okay. So this presentation will be about machine learning based land use land cover. I will start by first introducing the territorial planning pilot that is part of the NextGeos project, and then introduce the machine learning methods and the processes that we use to create a good quality land use land cover maps. And finally, I will end with an example that illustrates all this process. First, the territorial planning pilot. We want to create products that are used by territorial planning institutions to make better decisions. For example, land use land cover maps can be used by the Portuguese government to decide where to build the next road or where to build a new building. The final objective of this pilot is to have a web environment where we allow the user to create land use land cover maps, analyze the change in land use land cover in an area, and perform feature detection. The territorial planning entities we are collaborating with now are the Portuguese National Institution for Territorial Planning and the Lisbon Municipality. The version 1 that we are working on right now, we want to provide the users with a trained machine learning model that is capable of creating land use land cover maps for Sentinel-2 products. We are training this model specifically for the metropolitan area of Lisbon, and this is the version 1. For the version 2, we want to allow the user to customize pretty much everything. The user can define what is the data set, what is the model, what are the parameters of the model, and then he can obtain a trained model that is specifically designed for his data set and for his area of interest. And now for the part I find most interesting, the machine learning. I will describe here the processes we follow and the methods we use to create good quality land use land cover maps. We first start by processing the image. We need to perform atmospheric corrections. We are using the Centaur tool. Next, we need to either upscale or downscale the image, depending on our target resolution. For the Sentinel-2 data products, some bands come in different resolutions, not all bands come in the same. So we need to scale those bands to the same resolution. Then we crop our data product to an area of interest and apply a cloud mask. This cloud mask is important because areas that are covered by clouds contain values that are not useful for us and will only confuse our machine learning model and reduce its performance. We can now generate some new bands, some spectral indices. These new bands try to gather information to help the model distinguish between the specific zones and the rest of the image. For example, the normalized difference water index separates or helps the model separate the water bodies from the rest of the image. The normalized difference vegetation index helps the model separate the vegetation from the rest of the image. And we also have the normalized difference build index that helps differentiate the buildings from the rest of the image. Another very important aspect is to standardize the data. If we don't do this, the models will be biased towards features that have larger values, and we don't want that. In terms of data noise, we consider two things. There's a class, most of the times there's a class imbalance in the data set, and there are also some outliers. If we do not remove this class imbalance or correct it in some way or to some degree, the model will most likely be biased towards the majority class. And if we do not target the outliers and remove them, these are some elements of our data set that do not follow the trend of the other elements. They are considered noise in the data set, and our model will be impacted negatively. The performance will be impacted negatively because of these outliers. So it's important to remove them. And you can see that this process I've described has many variables. So what events to use, what standardization method to use, what resampling method to use, what machine learning method to use, and all of these methods also have parameters. And unfortunately, there is no direct way to tell what combination is best. So the way we define this and the way we set all these parameters, all these different parameters, is by doing grid search. We define a set of possible values for each parameter, and we train all the different combinations. And at the end, we have a report of all the results of these experiments, and then we can make decisions based on those results. In terms of machine learning algorithms, we use the classification algorithms. We use 4 different ones in our preliminary tests. We tried the random forest, which is an ensemble method that uses decision trees as a base classifier. Also, support vector machines. This is a non-probabilistic binary linear classifier, but it can also be used for non-linear classification by using kernels, and can also be used in multi-class classification by using multiple binary classifiers. For example, in our use case, the land use land cover, we need to use this multiple binary classifiers because land use land cover is a multi-class classification problem. We also look at the nearest neighbors algorithm. This algorithm classifies each element based on the class of its neighbors, and also AdaBoost. In AdaBoost, we have the concept of weak learners. In our case, our weak learners are decision trees, and we train each weak learner, and the next weak learner to train will take into account and will be tweaked in favor of those instances that were misclassified by the previous classifiers. So we adapt continuously to the errors we are making in the process. Here we have an example of some of our results. We implemented all our methods using the scikit-learn toolbox in Python. This example uses a support vector machine with these parameters. We obtained an F1 score of 77%, which isn't the best, but it's already quite good. We can see in the confusion matrix that the model sometimes confuses agricultural zones with forests, and we can't blame it much for that because they sometimes can be quite similar, but it's something we need to still work on. And now for a more hands-on example to explain all the process of what it really means and what are the outputs of each process. We start with the Sentinel-2 data product. We define our area of interest. We crop the data product to that area of interest. And then we combine the Sentinel-2 product with the ground truth labels. In this case, the ground truth labels are obtained from the Portuguese Territorial Department. And then combining the Sentinel-2 data product with the land use land cover ground truth labels, we can train our model and make predictions. Here we can see that the ground truth and the predictions are very similar images, which means that our preliminary tests are obtaining quite good results. Okay, so I think that's it. Thank you very much for your attention.
Thank you very much, Ivo. That was very interesting. So, yes, very interesting indeed. When we hear about artificial intelligence in media, it is very often related to cars or to individuals. but this is actually a very good demonstration of how artificial intelligence is being applied on Earth observation. So I'm very happy. I was very enthused to hear about this. You feel free to ask questions, like I said, in the chat box. If you have questions to Ivo, I will look for. They are over there. I will look for your questions. But first, so while we wait for that, I'll ask you a question, Ivo. You said that you combine Sentinels with ground truth data from the Portuguese mapping authority or similar to that. Is that the Portuguese official terrain model you are referring to, or are that terrain model involved at all?
So to train machine learning models, we need training data. This training data needs to have the inputs. In our case, the inputs, it's the satellite data that you can obtain for everywhere around the globe. And then we need the most important and the most difficult thing to obtain is the labels. So in our case for land use uncover is, okay, this pixel here, it's agriculture. This pixel here, it's forests. This pixel here, it's a building, for example. That data is quite difficult to obtain, and it's very costly in terms of time and people resources. So we are trying to create machine learning models to do that for us. But to train those models, we need that information first. That information, in our case, is obtained from the Portuguese Department of Territorial Planning. They did in 2015 a study for the whole area of Portugal, and they did it by, it's a mixture between doing it by hand and doing it with automated tools. But yeah, we are using that data to combine with the Sentinel data and then train our models.
Right, so it's not really the terrain you're interested in, it's the use of the land that is the interesting parameter for you. Yeah. Okay, if you come, I don't see any questions right now, so if you have questions after Carol has spoken, there is still a chance to ask Ivo questions. Now, Carol, let's see, I think we will talk about another approach to learning about terrain or land. In your presentation. Go ahead.
Yeah.
And he will be here soon.
Do you see my presentation?
It's a little bit slow, so I think I will recommend right away that you speak also not the fastest. Thank you.
Okay.
Go ahead.
Is there a presentation?
Yes, it is.
Yeah. Okay. My presentation will be focus on a little different type of users. Yes, this task of artificial intelligence usually is used by expert to receive something from data. If we have such data, yes, then very often this data has to be used by users who are not direct expert in geospatial technologies, who are not know what could be OGC standard and all things, and they don't understand such things like web map services, web feature services, and other how to optimize the scales of map and all these things. Yes, we have for our community many different tools. We have this OGC specification, WMS. It is good for expert, but it is not optimal for non-expert people. And I will go to the history, how we start with map composition, and I will explain the development. Something like 10 years ago, we start to develop Czech Inspire geoportal, and what was recognized that people who will use this geoportal, probably not all will be experts. Yes, we had in this time some specification for Inspire, which services could be used, how these services could be used, but this is really for the expert. And we start to thinking about such issues that probably normal people don't want to use services, don't want to know about OGC, but they need to have maps. And here at first, in this portal, we implement the map composition. Map composition is some combination of different, could be OGC now, not only OGC services, and you have to store this information about this composition. You can make metadata about such composition, and people then can work not with all these services, but they can call the topics which is interesting for them. You can see here there are different type of map composition, and you are then this map composition, as you can see, is some composition of different services which are already by expert optimized for different scale. In this time, when we develop this Czech Inspire geoportal, we start with OGC standard web map context. This standard is now almost dead because this standard had some limitation, and because we recognize this limitation, we start to work on our own solution, and we design some schema how we can describe the map composition. This schema is available on GitHub, and if you will be interested about this, you can study this on the GitHub of Ahrefs software, Ahrefs NG software, which was the first who fully implement the work with this schema. Later, we start extended this idea in two projects. First was SDI for apps, and where you can look on the blog of SDI for apps about some articles where we explain why this map composition is needed and how it can help share information that if we are speaking, for example, about citizen science or voluntary data, we can thinking not only about collecting point, display point, but we can start thinking sharing the map. I will prepare some map, and I am able to share this map with other people, and other people can use this map. So we start to change a little look on the voluntary geographic information, and if when presentation will be ready, you can go on this link and you can read some ideas and blogs about this topic. Second project where we continue with this concept was Open Transport Net project, and there we work with really group of non-experts. It was people from the cities and other. And again, we discussed all time how these people can use geospatial information, what they can do, what will be the best way to give them. And we work a lot on this concept of sharing the map and map composition. I put here some link on some series of articles which are on LinkedIn, which I publish on the LinkedIn, and you can see here the list and explanation of all this concept of map composition and working with this map composition in the detail. And now we will go to the Liberec Atlas of Environment. This is something what is now paid by Liberec region, what is supported by Plan for All and other organization, and this is some space for children, young people, where they can learn about maps, but also about environment, and then can also use some games which can help them understand the problems of environment. This atlas is in Czech because it is for the children in Liberec region, but you can see some basic principle. And here is also some list of composition which are available, which are prepared by expert, and this composition can be then, for example, embedded into web pages. You can select this composition, you can have thematic maps, and you can combine these thematic maps with the text which is explaining the problem, and you can see this immediately on online map. So this is one thing. Now you can tell, okay, it's nice, but you are speaking about social environment for sharing the data. So the first thing is that the solution support sharing the data on social media, and you can your maps share through Twitter or Facebook. If you have, or if you will prepare some good interesting maps, you can easily share this map through the social media, and other people can use these maps. This is one step, but till now it is limitation, yes, because till now you see this data only on your portal. So we start to thinking how we can extend it, this possibility, or what we can do to overcome this limit. I mentioned that we have the description of this map composition also in the metadata. We are using standard protocols ISO 19115 for description of the metadata, but we are also able to share this metadata in RDF, so we have also this metadata in semantic form. And this metadata as are showing or giving you URL of this map composition description as some any type of the services. And here is already the way how could be the data shared and used by other platform. We started first, and in the relation with the hackathon, and it is now already developed. And next week during the hackathon, all this plugin will be published. We start to work with QGIS, and we start to develop or implement the possibility how to use in QGIS all this map composition which are now on Liberec region. So here you can see the map on the Liberec region portal, and there already exists plugin for QGIS which is able to discover ISO 1915 meta or 119 metadata, and you can see that we have there not only services, what is the standard way how the data are shared, but we have there also application. And we extended the plugin, and we develop additional plugin, and with this you are very easily able to display all this data, all these services on QGIS. So this is one step to make this map composition available for any platform. We are also trying to make the test on leaflets, and we plan to extend it, this possibility that the data will be in the future shared among many platforms, but they will be also the possibility to combine with other VGI functionality. So I would like to thank you. This is all from my presentation.
Thank you so much, Karol. It looks like a very interesting project for a variety of users. Let me click the wrong button, the unshare, not the wide screen. Can you unshare and
I stopped. I stopped.
Yeah, you stopped, but you. Oh, maybe I was the one. I was the guilty one. So, yeah, welcome back, and thank you so much for this very interesting presentations, both of you. If there are any questions to Karol and to Ivo, for that matter, there is still room to. We have time to answer them some questions. While you are typing, I will do some encouragement to join us in the Inspire Hackathon. Today is the deadline for registration in the Inspire Hackathon, in the Prague Inspire Hackathon. The Inspire Hackathon family, or this is a satellite Inspire Hackathon. The concept is that we have the hackathon going on for some time virtually beforehand. So the groups are forming and working virtually. And then we all gather in this case, in Prague, for a final, concentrated work, final hack. And the finale will be on the 23rd of January in Prague. If you cannot travel to Prague on such a short notice, it's still possible to join some of the teams and be presented by the rest of the teams in Prague. So it's possible to work virtually all the way to the end if you join one of the teams. If you want to create a team, you have to hurry, and you have to have at least one person going to Prague. But we really encourage you to be joining this. As I said, the Inspire Hackathon is not, well, as I said, it's Karol who says this, because Karol is one of the godfathers of the Inspire Hackathon concept. The concept is so that we have one Inspire conference together with the Inspire Hackathon together with the conference, the Inspire conference every year. And in between, we also organize these so-called satellite hackathons. And this is a way for us to maintain a contact, to maintain the community of experts of all ages that we talked about in the beginning. You are all welcome to join this. We want, it's really a very open community. And if you are interested in any of the topics, you are more than welcome to join us. If you have any questions, I don't see any questions. Then I will give the floor to the speakers. Do you have any final comments or additional information that you want to share?
Well, no, I think I will give you the slides so for you to share after we are done with the webinar. So if people want to contact me for any reason to discuss something, they can contact me by email. I have the email on the presentation, so I will always be available to discuss machine learning. I'm very interested in it.
Thank you for that.
Go ahead and ask questions.
Thank you for that, Ivo. We will post this, both the replay for those of you who are registered, who are here. You will get the replay in your email box, but we will also post these replays on Plan for All, and after the hackathon itself, it will also be available on nextgeos.eu with the presentations as Ivo offered you. And so thank you for that, Ivo. And Karol, any last comments, encouragements?
Yeah, of course,
you want to share?
My presentation will be also available. Yes, so if you will be interested, you can contact me. In any case, yes, we are now trying to use this approach with different communities, and we are ready to work on could be some educational or other activities with this concept, because all solution is fully based on open sources, yes, and it is possible, easy to reuse for the different tasks, different places. So if you will be interested, you are welcome. Please contact me.
Yes, indeed. And I let that be the last word from us today. If you're interested, if you're here and have time to join our last webinars in this series at 3 o'clock today, you can register via our social media handles. We are Plan for All on Twitter, and we also Plan for All on Facebook. You can also find information about this on NextGeos social media, which is NextGeos. Just follow NextGeos. Okay, thank you so much. Thank you, audience, and thank you, speakers.
Okay. See you. Bye.
See you. Bye.